Welcome to this gentle evening lesson, a quiet exploration into the science of stress. If you've ever found yourself pondering the subtle interplay between your busy days and your restful nights, you're in precisely the right place. We're going to journey through the intricate pathways that connect your mind, your anxieties, and the very rhythms that govern your body, all before you drift off to truly restorative sleep. Now, stress itself is a word we use rather casually, isn't it? Yet beneath its common usage lies a profoundly complex scientific reality. Think of it not as a singular entity, but as a vast, ancient river, sometimes a gentle stream, other times a roaring current. This river flows through all of us, shaping our landscapes, both inner and outer. For tonight, we'll focus on what it truly means for your physical being, your delicate internal mechanisms. You see, the human body, in its magnificent wisdom, possesses an elaborate system designed to protect itself from perceived threats. It is a system honed over eons, ensuring our ancestors survived saber-toothed tigers and harsh winters. But here's what's interesting. In our modern world, that same system often responds to deadlines, traffic, or even just our own thoughts as if they were those ancient, primal dangers. At the heart of this intricate dance is something scientists refer to as the HPA axis, the hypothalamic pituitary adrenal axis. Imagine it as a finely tuned orchestra conductor within your brain. When a stressor, that roaring current in our river metaphor, appears, the hippocampus, a part of your brain deeply involved in memory and emotion, quickly assesses the situation. It then signals the hypothalamus, which, like our conductor, sends a message to the pituitary gland. This, in turn, gently prompts the adrenal glands, perched atop your kidneys, to release a hormone you've likely heard of, cortisol. Cortisol, often termed the stress hormone, is not inherently bad, quite the contrary. It's a vital messenger, a powerful surge designed to mobilize your resources. It raises your blood sugar to give you immediate energy, sharpens your senses, and temporarily suppresses non-essential functions like digestion and immunity. All of this is wonderfully adaptive for a short sprint, for escaping that tiger. But what happens when that sprint becomes a protracted marathon? What happens when the river of stress never quite recedes to a gentle stream? That, my friend, is where our bedtime lesson truly begins to unfold. Stress, friend or foe? Indeed, this secret battle wages on, often beneath the surface of our awareness, but its echoes are felt throughout the entire bodily landscape. One of the most ancient alarms, a system honed over eons, lies deep within us, waiting to be activated. This is the intricate dance of our stress response, a symphony of hormones and neural pathways designed for one purpose: survival. You see, when our ancestors faced a predator, a saber-toothed tiger perhaps, their bodies needed to react instantly. No time for reasoned thought, no opportunity for leisurely contemplation. Their very survival depended upon an immediate cascade of biological changes, a primal surge of energy. This instantaneous shift, this profound alteration, is orchestrated by what scientists often refer to as the hypothalamic pituitary adrenal, or HPA, axis. It's a rather unassuming name for a network that wields such immense power over our physical and emotional well-being. Think of it as a central command center, nestled deep within the brain, continually monitoring the world both outside and within. When a threat, real or perceived, is detected, this HPA axis springs into action. It's like a silent alarm going off in the control room, sending urgent signals down carefully established lines of communication. Hormones, these tiny chemical messengers, become the swift couriers of this urgent news, traveling through the bloodstream to distant outposts, preparing every cell for immediate defensive action. This entire system, delicate yet robust, explains why a sudden fright can make your heart race, your breath quicken, and your muscles tense. It's the body's way of saying, "Attention, prepare for action." This isn't merely an emotional reaction, it's a deeply ingrained physiological one, carved into our very being by the demands of a perilous past. Ancient alarms activate. Indeed, last time we began our quiet exploration into the nature of stress itself, asking whether it is truly a foe or perhaps at times even a friend. We touched upon its ancestral echoes within our ancient physiology, its role in guarding us against immediate peril. But the story, you see, is far more intricate. When we speak of stress, there is a particular orchestrator you might be wondering about. One at the very heart of this drama, the hormone known as cortisol. It is the body's primary conductor in moments of pressure, a chemical messenger deeply intertwined with our sleep, our wakefulness, and our very essence. Think of it as a vigilant sentinel, always on duty, yet even a sentinel, if overworked, can begin to falter. What's particularly fascinating about cortisol is its daily rhythm. Imagine a gentle, invisible tide within you, ebbing and flowing with the sun and moon. Ideally, its levels are at their lowest around midnight as you drift into the quiet harbors of sleep. Then, as dawn approaches and the world begins to stir, cortisol gradually rises. reaching its peak about an hour after you awaken. This morning surge, so to speak, is what helps you shed the blankets of slumber and greet the day with a certain clarity, a readiness for its demands. This dance between cortisol and our internal clock, our circadian rhythm, is a delicate ballet. When this dance is disrupted, when the sentinel is confused by the modern world's ceaseless demands, profound shifts can occur within our physiology. Perhaps you've felt it before, that lingering unease, that sense of a motor running even when it should be quiet. What this means is when the body's stress response becomes a constant hum rather than an occasional alarm, when cortisol levels remain stubbornly high, especially at night, the very foundation of restorative rest begins to erode. This relentless presence of cortisol, this constant state of vigilance, can fragment our sleep, making it shallow and restless. It can stretch the time it takes to finally surrender to slumber, and leave us feeling anything but refreshed upon waking. In essence, the mechanism designed to protect us in short bursts of danger can, over time, become a quiet saboteur of our deepest peace. Understanding this subtle interplay, this nightly performance of internal chemistry, is, I believe, key to grasping the wider narrative of how stress truly molds our bodies and minds. The cortisol cascade begins. The physiological response to stress, you see, is a delicate dance between ancient survival mechanisms and the modern world that constantly prods at them. When our early warning systems, those ancient alarms we spoke of, detect a threat, real or perceived, a cascade of events unfolds throughout the body. It's like a silent internal symphony, where each instrument plays a crucial, interconnected role in preparing us for action. One of the central players in this drama is a remarkable system known as the HPA axis. That's the hypothalamic pituitary adrenal axis. Think of it as your body's primary stress response control center, a sophisticated communication network between your brain and your adrenal glands, which sit atop your kidneys. When the brain perceives stress, it sends signals down this axis, culminating in the release of certain hormones, chemical messengers designed to galvanize the body. Among these messengers, cortisol stands out. It's often called the stress hormone, but that label perhaps doesn't quite capture its full complexity. While cortisol certainly rises during stressful times, it also plays a vital role in our everyday rhythms, peaking in the morning to help us wake up and gradually declining throughout the day. It helps regulate our sleep-wake cycle, enhances our alertness, and even influences our mood. Imagine it as a diligent manager, usually keeping things in order. But under stress, cortisol's role shifts from manager to emergency responder. Its levels surge, providing the body with a quick burst of energy by increasing blood sugar. It also helps to suppress non-essential functions like digestion and the immune system, thereby channeling all available resources towards dealing with the immediate threat. This is incredibly useful if you're facing a literal saber-toothed tiger. However, in our contemporary lives, the saber-toothed tigers are often deadlines, financial worries, or persistent anxieties. These don't require physical flight or fight, but they still trigger the same ancient hormonal responses. What happens then when cortisol levels remain elevated for extended periods? Well, the body isn't designed for constant emergency mode. Persistent high cortisol can lead to a host of issues, from disrupted sleep patterns to a weakened immune system and even changes in our metabolism. Here's what's interesting. The very system meant to protect us can, if chronically overstimulated, begin to cause problems itself. It's a subtle irony in our biological design. But to fully understand this, we must delve deeper into another key player in this stress response, a rapid-fire chemical messenger that often works hand-in-hand with cortisol. Perchance you might be familiar with its name, adrenaline. Adrenaline, your inner beast. The physiological response to stress, you see, is a delicate dance, a finely tuned ballet of our internal systems designed for survival. When we encounter something perceived as a threat, perhaps a sudden loud noise or a looming deadline, our sympathetic nervous system springs into action. Think of it as an ancient alarm system honed by millennia of evolution. It prepares the body for what scientists often refer to as the fight or flight response. Now, at the heart of this intricate system is a small but profoundly influential region of the brain called the hypothalamus. This tiny area acts as the commander-in-chief, initiating a cascade of events that ripples throughout our entire being. It sends signals to the pituitary gland, which in turn communicates with the adrenal glands nestled atop our kidneys. This chain of command, as we discussed previously, is known as the hypothalamic pituitary adrenal, or HPA axis. It's a marvel of biological engineering, designed to rapidly mobilize resources. The adrenal glands, upon receiving their orders, begin to release a potent cocktail of hormones. Among these, cortisol stands out as a central player. Cortisol, often termed the stress hormone, helps to fuel the body for immediate action. It increases the amount of sugar in your bloodstream, ensuring that your muscles have plenty of energy. It also suppresses non-essential functions like digestion and the immune system to prioritize immediate survival. But here's what's interesting. This system, while brilliant for short-term crises, was not designed for the chronic, low-level hum of modern life. Our ancestors faced acute dangers, a predator perhaps, or a sudden storm. Their stress response would surge, then quickly recede once the threat had passed. However, today our minds are often plagued by persistent worries, work pressures, financial anxieties, social complexities. These challenges, though rarely life-threatening, can keep our HPA axis perpetually engaged, tricking our bodies into believing they are constantly in danger. What this means is that cortisol levels, which should naturally rise in the morning to awaken us and gently taper off towards evening, can remain elevated for extended periods. This disruption, this continuous surge of stress hormones, can begin to throw other bodily systems out of balance, setting the stage for a host of unwelcome consequences. It's like leaving the engine of an automobile running at high RPMs for too long. Eventually, components begin to wear down prematurely, and the body, in its own delicate way, is no different. Fight-flight phrase. Adrenalina Kator amoilismi w rozdziel papazednim, jest nixim gwaltowni, bystri nert, Katori na chwal pr zispisa arziknes zigo istnienia. Lex wtlich krokatrelich, intensunich pr zipliwau, plinian na, glebsa arzeka, Katorop oyada history dilas ibardzie zilazona. Moyo cortizalu hormoni, Katori sizesto naziwemi hormonum stressu, Lex Katorgo rola jest zinaxni subtilniesa ibardzie w shetstrana nis samatilko rikjana zagrazni. Cortisol drogi slachaksu, jest jak surjni wykanaka w titas nes zigo sila. Jigo glona shana tu os podosgors pr zised kanadnerksa, Katora badexi pisksitlu nezuwaja oja hpa. Ta os tiskomplikoana psych signalochemicsnich zaxinajaka si w pedusgorzu, malaj lex nizwikal waznid sizeskai mozgu, Katora dizilajak centrum daudzenia. Wyabresmi to sobi, Jesli Wallace, Jocko Misterni Zeger, W. Ritmi Dobwim. Cortisol pawinian rosnek raz zipirusimi prominiami slanka, pr zygotojek nuzduektu naske, osiagjek swad shit okolo godzini 9 rano. Apodum stopniowo, przes kali dizin, jigo posium pawinian opadak, stajek sinednisim okolo palnasi, by pozwalik nam na zasluzini sen. To harmonani kolasini jest kluxo dla na zigo odpixinquai sizadnoskai, dla tej delicatnidron augi midziak tu nasia snem. To w lasni w timukledzi, midzi shitem cortisol rano jigo minimum prz zasnisim, krij si puyan spakaj swigo rdzajo biotnika regenerakji. Lex chronics ni strez 10, Katori towarzisi nam prz dilugi tigatni siziwy misies, biwanisnisnim dirigentum. On potrefi restroic 10, Misterni Zeger. Zamiast planigo spatku poziamo cortisolu w si gudinia, observujami jigo podwison stezeni w nosi. Kaz tu oznexa, kaz kidi posium cortisolu edizimuj si wysoko, gdy poino bike nisko trudno jest zasnek, asen not jesli najdzi biwaplitkia pr zerwini. Mazna budzik sirano I sizuk si jakbizmi w kalnai spali. To w lasni ti momenti w katorich nas silo zamiast zwolniak pozistik w gotowaskaj podtizimujek nudzilni Caesar, katori milizmi odlazik na chwel snu. To puksusinu Spania kator nistadi stage sidla wilukadzianasia. Brain under pressure. The delicate balance of fight, flight, or freeze, that ancient primal response to threat, is, as we've heard, a marvel of our biology. Yet when this system is overtaxed, when the echoes of danger linger too long, its very efficiency can begin to unravel the subtle threads of our being. Indeed, the science suggests that this prolonged activation, this chronic stress, casts a long shadow over some of our most vital functions, especially our memory. You might be wondering, how precisely does the relentless drumbeat of stress impact our ability to recall the past, or even to form new memories? And what does this mean for the very fabric of our daily lives? Imagine, if you will, the intricate architecture of our minds as a vast, ancient library. Within this library, certain sections are more delicate, more susceptible to the dust and disarray that comes with endless disturbance. The hippocampus, for instance, a small, seahorse-shaped region deep within our brain, is a particularly vital archive, crucial for forming new memories and helping us navigate spaces. It's also rather sensitive to the relentless currents of stress hormones. When acute stress strikes, a short, sharp shock, the hippocampus might actually enhance memory consolidation. It helps us remember the details of that dangerous moment, perhaps as a survival mechanism. But herein lies a critical distinction. Chronic stress, unlike its acute counterpart, does not invigorate. Instead, it seems to wear down these sensitive structures. Prolonged exposure to cortisol, the very hormone designed to help us respond to threats, can lead to a shrinking of the hippocampus. Think of it as parts of our mental library slowly becoming waterlogged or perhaps dusty and forgotten. The shelves warp, the books become harder to access. Baxla. And it's not just about size. The very structure of the neurons within the hippocampus can change. Dendrites, those branching extensions that receive information from other neurons, can retract. It's as if the delicate antennae of our memory cells are being pulled back, making it harder to catch new signals, to record new experiences. This can result in a discernible impairment in memory function, making it harder to learn new things or even to recall recent events. The pathways of remembrance become less clear, more circuitous. Baxla. This influence extends to other crucial parts of our brain. The prefrontal cortex, often seen as the brain's executive suite, responsible for planning, decision-making, and working memory, can also suffer. Its functionality is diminished under chronic stress, leading to a kind of mental fog. And the amygdala, that small, almond-shaped area deeply involved in our emotional responses, especially fear, tends to become overactive. It grows more robust, more reactive, much like a guard dog constantly on edge, barking at every shadow. This heightened emotional reactivity can further interfere with the clear processing and storage of memories. Our inner librarian, perpetually on edge, struggles to maintain order. Baxla. So what we begin to see is a complex interplay. The very systems designed to protect us when overwhelmed can begin to dismantle the tools we use to understand and navigate our world. The mist of chronic stress, indeed, can profoundly obscure memory's intricate pathways, making the past feel distant and the present at times harder to grasp. It truly is a testament to the unforeseen consequences of prolonged unrest within our own bodies, a quiet erosion of clarity. Memory's misty veil. The brain, under the subtle yet persistent weight of pressure, begins to reshape itself, an almost quiet internal metamorphosis. This isn't merely a feeling, you see, but a very real biological adjustment. It's as if the mental blueprint, the very architecture of our being, shifts in response to the world around us. Think for a moment of something called neuroplasticity. This rather grand term simply refers to the brain's remarkable ability to adapt, to change its structure and function. It's how we learn new things, how we form memories, and indeed how we respond to stress. When stress becomes chronic, however, a constant hum beneath the surface of our lives, this adaptive capacity can begin to turn maladaptive. The very circuits designed to help us survive, to thrive, can become, in a sense, overwhelmed, leading to what some might call an allostatic load, a cumulative burden upon our internal systems. Now, the amygdala. That ancient, almond-shaped part of our brain, often associated with emotions like fear and anxiety. Well, under acute stress, it activates almost like a sentinel standing guard. It helps to consolidate the memories of potentially dangerous events, making sure we remember how to avoid them again. Yet with chronic stress, this sentinel becomes hyperactive. Its volume might even increase, and its neurons, those tiny messengers of thought, actually grow more complex, more branched. This heightened activity, this persistent state of alarm, is often observed in those living with conditions such as depression and anxiety, influencing their very perception of safety and threat. And then there is the hippocampus, so vital for our learning and memory. It helps to regulate our stress response, ensuring that once the danger has passed, our internal systems can return to a state of calm. But this delicate balance can be profoundly disturbed by prolonged stress. High levels of stress hormones, particularly corticosteroids, can, over time, actually impair the hippocampus's ability to function optimally. Imagine, if you will, the delicate branches of a tree beginning to retract, to wither. This is somewhat akin to what happens to the dendrites within the hippocampus, the parts of the neurons that receive signals from other cells. This physical change contributes to deficits in memory and cognitive function, making it harder to learn new things and to recall existing information with ease. The prefrontal cortex, the very seat of our executive functions, decision-making, emotional regulation, and working memory, also experiences the subtle, yet profound, effects of enduring pressure. Acute stress might temporarily disrupt our ability to focus, to hold complex thoughts in our mind. But chronic stress, well, it can lead to more lasting changes. There can be a reduction in its volume, an impaired ability to control our initial emotional responses, and a general decline in the cognitive flexibility we rely upon for navigating the complexities of daily life. It is almost as if the captain of the ship finds it increasingly difficult to steer a steady course. Heart pumping harder. Pamatesi Jack Rosmoilismi Ostrizi. Iotim, zijigo slady by waja gleboki, sizasum not nudoxni golem okim, adas ti nudoxni slady. The sizesto zimini zakadzes w nasum sil naposiomi, katori dopiro ad nidona zaxanemi w pelni resumike. Wyabresi sobi stara, zabit kakasi, jej text, tanas jenny, nasa biologia, tanismina sizesknas samich, ale marginasi tej kasigi. Amaz nodeki pisin drobnim maxkim midzi wirsami, to w lasni epigenetica. To Jack Nas organism deciduj, Kator fragmenti tej ksigi prs exitak glosno, a Kator posistawic w sissi. Strez zw lasks a ten uporksui prs ulekli, to nixamadrexna uwaga, Kator z cizasum zmenia spasab, w Jacki Nas unidisni cizidalnik interpretuj t genetics na apoyes. To nizemenia amigo textu el spasab gigo occitania. I tamaragramni zinaxeni. Fascinudes gest, z epigenetica dotica not tak podstwaj proso jack metalacta DNA. Mazna to sobi wybrazic jocko mal, chemics ni zinaxniki, kator prs alexaja sidunas zigo kodu genetics nigo, decidjak o tim, czy dani gen bedzi actuni, czy posistani uspiani. Badania z 2017 roku, scupides synapactiontach sirpiesic nazespal kushinga, scores any characters ude synadmirin imposiumum cortisol y causally. ZT osobi mili niz za metalekji DNA. Ko tu oznaxa, ZPR zulekal wysoki stezani hormonu stresu. Zmenia ten epigenetics ni podpis, prawidzak du dilugatrolic consequentji, tak jack zmexeni, depresja czy lek. To tak jack bisilo pod w plium nedmir nigo stresu, zak zilo zapaminak, jack proidlowo regulo exwoj unitas ni mechanismi. Il epigenetica tenitilko rikja nustrez tu iteras. To ronis eco prs laskai, kator rezonuj prs pokolinia. Zw lasks a tw chesni doswig Nikorzis ni widerzenia zdzisinstva, taki jack slabo pieka masterzynska lub trauma, pozostowiaja w lasni epigenetics ni rezenia. Zminiaja metalakji DNA w genek, kator reguluja nasa odpoids nustrez. A kosiko stressori, kator wistapuja w chesnim ede paisaisha, maja zinaxni wiksi itirualsi w plio. Misty, Kator Padriaja Psi W Dorslaska. Jest to nixim fundament zbudwini W dzinstwi, jestli jest on niestabilni kala konstrukcja Kator bujajami poznie, maz bike bardzie podatna na ziniskzeni, wyabresi sobi cesarna mak pod W plium silnigo stressu, jed discomfort, jedlek, maz physics ni zminik razwad pladu. Dzinjsai to papazes mechanismi epigenetics ni zmiani w metalakshi DNA, w regioni genuad podzilnigo za receptor glycocorticoidui, tigo, katori modulud nasa rikshna strez, t zmiani. Mogatiruak not po uridzenu, w pliudak nutu, jack dziko bedzi rigoak na strez w piarzislaska. To pokazu jack gleboko zakorzeni na jest tasaik pauyas and midzi nasami daswik siniami, nasami genami. I nasim zdrawim, zadum epigenetic uxi nuz, zistrez ni jest jedini ulitnim stainum umislu. Jest on pots nasila katora maz pr zeprogramak nas biochemics ni massini, zmenia dexigeneric nasit geno, tenai zmenia textu samid kasi gizaisha. El modificut spasab, w jaki ta kasiega jest cizitana. Itima w pliu na kaz de stron nasij osibistage histore. Gut feeling, gut stress. When stress becomes a constant companion, when the heart is continually pumping harder, it begins to reshape us, not just in our immediate reactions, but in the very fabric of our being. This prolonged state, this ceaseless vigilance, starts a cascade of changes that reach into the quiet corners of our brain and even into the delicate machinery of our genes. Now you might be wondering, how does something as intangible as stress leave such deep and lasting imprints? What happens is a subtle yet profound alteration in the brain's landscape, a process we refer to as neuroplasticity. This isn't just about learning new things, it's about the brain's ability to change its structure and function. Think of your brain as a vibrant garden. In times of balance, it flourishes, growing new connections, new pathways. But under the relentless sun of chronic stress, certain areas of this garden begin to wither while others may become overgrown. One of the regions particularly affected is the hippocampus. This area, nestled deep within your brain, is crucial for learning and memory. It's also deeply involved in regulating your body's stress response. Under acute short-term stress, the hippocampus can even enhance memory, helping you recall immediate dangers. Yet the persistent onslaught of chronic stress literally shrinks parts of the hippocampus. Its delicate branches, its dendrites can retract, and the very generation of new brain cells, a process called neurogenesis, slows considerably. Imagine a quiet library where new books are constantly being added. Chronic stress. It's like halting that flow of new knowledge, leaving the existing shelves to slowly empty. Then there's the amygdala, often called the brain's alarm bell. It's involved in fear and emotional reactions. Unlike the hippocampus, which tends to shrink, the amygdala under chronic stress can actually enlarge and become overactive. It's as if that alarm bell becomes perpetually sensitive, ringing even at the slightest rustle of leaves. This heightened activity can leave us feeling persistently anxious, always on edge, always prepared for a threat that may not even exist. The prefrontal cortex, the brain's executive control center, is also affected. This is where we make decisions, regulate our emotions, and plan our actions. Acute stress can momentarily disrupt its function, making it harder to think clearly, but chronic stress, that can lead to a sustained weakening of this vital area. It becomes harder to make sound judgments, to control our impulses, and to maintain our emotional balance. It's like the conductor of an orchestra suddenly struggling to lead, causing the entire symphony to fall into disarray. What is most fascinating and perhaps unsettling is how these changes can even manifest at the genetic level, influencing what we call epigenetics. This doesn't alter our fundamental genetic code, no. Instead, it's akin to adding tiny notes in the margins, instructing our genes whether to express themselves more or less, to turn on or off. Chronic stress, particularly early in life or even prenatally, can leave these epigenetic tags, modifying how our stress response systems function for years to come, sometimes even across generations. This is a subtle dance between our environment and our DNA, a dance where stress, unfortunately, often takes the lead. Sleep's delicate dance. Now, as we navigate this intricate landscape of stress and sleep, we arrive at another profound connection: how stress seems to reshape the very architecture of our brains, a process known as neuroplasticity. Think of neuroplasticity as the brain's incredible ability to adapt, to change its pathways and connections in response to experiences. It's how we learn new skills, form memories, and adjust to new environments. However, this same adaptability, while vital for survival, can also become a vulnerability when confronted with chronic stress. You see, when stress becomes a constant companion, this very plasticity can go awry, leading to maladaptive changes that contribute to mental health challenges. It's as if the brain, in its attempt to cope, starts building pathways that are less about thriving and more about surviving in a state of perpetual alarm. Consider the hippocampus, a small, seahorse-shaped region nestled deep within the brain. It's crucial for learning and memory, and it plays a significant role in regulating our stress response. However, under the relentless assault of chronic stress, researchers have observed a fascinating, if concerning, phenomenon. The dendrites, those tree-like branches of neurons that receive information, can actually retract. It's akin to a tree losing its leaves and branches, limiting its ability to gather light and nutrients. This structural change compromises the hippocampus's function, potentially affecting memory and our ability to manage stress effectively. Simultaneously, another area, the amygdala, often thought of as the brain's alarm center, exhibits almost the opposite reaction. With chronic stress, the amygdala can become more active, even enlarged. Imagine an alarm system that becomes overly sensitive, constantly blaring at the slightest rustle. This heightened activity in the amygdala contributes to feelings of anxiety and fear, making us more reactive to perceived threats, even when none truly exist. What's particularly intriguing is the influence of our early experiences on this cerebral plasticity. Just as a sapling bent by persistent winds might grow into a tree with a permanent curve, early life stress can profoundly shape the brain's development. Studies have shown that adverse experiences in childhood can lead to epigenetic changes, subtle modifications to our DNA that don't alter the genetic code itself, but rather dictate how genes are expressed. These epigenetic changes can make certain genes more or less active, influencing our stress response and vulnerability throughout life. For instance, a child exposed to chronic stress might develop an HPA axis, that central stress response system we discussed earlier, that is perpetually on high alert. This can be viewed, in a sense, as an adaptive response to a harsh early environment, preparing the individual for a world perceived as constantly threatening. However, in a calmer, safer environment later in life, this adaptation can become a burden, contributing to anxiety disorders or depression. It's a remarkable, if sometimes tragic, testament to the brain's enduring capacity for change. And it is this very plasticity, this ability to change, that also offers a glimmer of hope. For if the brain can be shaped by stress, might it not also be reshaped by interventions designed to promote well-being? What if we could, as it were, encourage new growth and healthier pathways? We will explore this further as we turn our gaze towards the insidious nature of insomnia. Insomnia's silent seed. Now let us turn our gaze to the subtle dances within the human form, particularly the intricate interplay between stress and our fundamental biological rhythms. Sleep is not merely a passive state of rest, it is an active, delicate dance of hormones and neurons, carefully orchestrated to maintain our well-being, and when stress enters this dance, its steps can become quite erratic. You see, our body's primary stress response system, known as the HPA axis or the hypothalamic pituitary adrenal axis, is deeply intertwined with our sleep-wake cycle. Think of it as a finely tuned clock, governing not only how we respond to perceived threats but also when we feel sleepy and when we wake. Cortisol, our body's main stress hormone, typically follows a very predictable rhythm throughout the day. It's usually at its lowest around midnight, gently rising through the night and peaking about an hour after you naturally awaken, perhaps around 9 in the morning. This morning surge of cortisol helps us feel alert and ready for the day ahead. However, when this delicate balance is disrupted by stress, the HPA axis can become profoundly dysregulated. Chronic stress or even short-term acute stress can cause cortisol levels to remain elevated far beyond their natural rhythm. Imagine that morning surge of cortisol, but extending deep into the evening or even through the night. What this means is that when your body should be preparing for sleep, it's still receiving signals of alertness, making it incredibly difficult to drift off. This sustained elevation can lead to fragmented sleep, a reduction in the total amount of sleep you achieve, and of course, the pervasive feeling of insomnia. Now you might be wondering, is it stress causing the poor sleep or poor sleep exacerbating the stress? It is, alas, a rather insidious two-way street. Insomnia and chronic sleep deprivation can, in turn, increase cortisol secretion during the day, further amplifying that feeling of vigilance and making it even harder to relax into sleep the following night. It becomes a persistent, draining cycle. A quiet struggle between the body's innate desire for rest and the constant physiological alarms triggered by an overactive stress response. Immunity is hidden tall. Now, as we have journeyed through the subtle ways sleeplessness can touch us, it becomes important to understand how stress, that persistent companion in our modern lives, truly shapes our sleep. You see, for many, stress isn't just a fleeting moment of anxiety. It's a continuous low-level hum that influences our very biology, often without us even realizing it. Think of it this way: our bodies have an ancient alarm system designed to protect us from immediate dangers. When this alarm sounds, a symphony of hormones is released, one of the most prominent being cortisol. This cortisol should ideally rise in the morning, gently waking us and preparing us for the day ahead, and then gradually recede as evening arrives, allowing us to drift off to restorative sleep. What happens, though, when stress becomes a constant presence? This careful rhythm, this circadian dance, can be thrown entirely out of sync. Instead of dipping low in the evening, cortisol levels can remain stubbornly elevated, keeping our minds and bodies in a state of heightened arousal. It's as if the alarm system never quite switches off, and we are left perpetually on guard, even as we try to rest. This in turn can manifest as that frustrating inability to fall asleep, or as frequent awakenings throughout the night. It's a circular challenge, isn't it? Stress disrupts sleep, and a lack of quality sleep then makes us more vulnerable to stress. Each reinforces the other, creating a cycle that can be incredibly difficult to break. This is why you might find yourself lying awake, your mind replaying the day's events, or perhaps conjuring up worries about tomorrow. This rumination, this endless turning over of thoughts, is a hallmark of stress's insidious effect on our nocturnal peace. It's a testament to the mind's difficulty in simply letting go when it feels perpetually threatened or overwhelmed, and what's particularly fascinating is how this delicate balance of hormones and internal rhythms can further influence broad aspects of our physical well-being. This is not merely about feeling tired, it is about profound systemic shifts within the body. What then are some of the long-term echoes of this persistent internal alarm? Well, when cortisol remains elevated, it can nudge our systems toward particular patterns. Patterns that over time might contribute to deeper, less immediately obvious changes in our health, shaping the very landscape of our physiology. Inflammation, body's fire. The intricate dance between our sleep and these profound changes is truly a tapestry woven with delicate threads. When sleep becomes fractured or simply insufficient, the very rhythms of our body begin to falter. Think of it like a grand clock, its gears turning less smoothly, its chimes ringing at imprecise moments. This disarray, you see, extends to the rhythmic release of our hormones, those subtle messengers that guide so much of our waking and sleeping lives. You might be wondering, what particular components of this complex symphony are most affected? Well, the spotlight often falls on the hypothalamic pituitary-adrenal, or HPA axis. This is the body's central highway for stress response, and its activity under normal circumstances follows a very clear 24-hour cycle. Cortisol, often thought of as the primary stress hormone, is highest in the morning, gently preparing us for the day ahead, and then quietly recedes to its lowest point around midnight, inviting us to slumber. But when stress becomes a persistent companion, or when sleep is continually denied, these delicate rhythms warp. Indeed, even a partial deprivation of sleep, perhaps just 4 hours a night for a mere 6 nights, can dramatically alter this cortisol production. Instead of dipping low in the evening, readying the body for rest, cortisol levels remain elevated. It's like the body stays on high alert, a sentry perpetually scanning the horizon for danger, even when no threat exists. This means, naturally, that the body struggles to initiate deep, restorative sleep. And this, in turn, perpetuates the cycle. Poor sleep leads to dysregulated hormones, which then lead to even poorer sleep. Now here's what's particularly fascinating. The physical architecture of sleep itself can be altered. Sleep, as you know, is not a monolithic state. It has its stages. The lighter stages before we descend into deep, slow-wave sleep, and then the enigmatic REM sleep where dreams often unfold. When hormones like CRH, corticotropin-releasing hormone, and the glucocorticoids are in excess, they can actually reduce the amount of slow-wave sleep we experience and even shorten the latency to REM sleep. This suggests that the very quality and structure of our nightly rest are being reshaped by this internal disharmony. It's as if a quiet builder is at work during the day, subtly altering the very foundations of our night's sanctuary. And these changes, though unseen, have profound reverberations throughout our entire physiology. Hormone harmony lost. Indeed, when we speak of this intricate dance between stress and sleep, we must consider a critical mechanism, the very structure of our brains. Imagine, if you will, the brain as an ancient library filled with countless scrolls of knowledge and connection. This library is ever-changing, ever-adapting, a concept we term neuroplasticity. It is the brain's remarkable ability to reorganize itself by forming new neural connections throughout life. While traditionally associated with learning and memory, neuroplasticity also plays a profound role in how we respond to stress, and how that response in turn shapes our sleep. You see, chronic stress, that slow, pervasive current we've often discussed, can over time begin to alter the very architecture of this internal library. It can lead to a kind of, shall we say, disarray in certain key sections. Some areas might become overactive, like a section of the library where the archivists are constantly in a heightened state of alarm. Other areas might withdraw, becoming less accessible, less connected, as if certain scrolls are being put away and rarely consulted. What this means in more precise terms is that stress can affect the structural and functional plasticity of our neural networks. We're talking about changes in the morphology of our dendritic spines and dendrites, the tiny branches and connections between neurons, and even in certain instances, neurogenesis, which is the birth of new neurons. Think of it as the construction of new bookshelves and the addition of new librarians. Chronic stress, particularly in areas like the hippocampus, a region crucial for memory and emotional regulation, can lead to a shrinking of these neuronal branches, a kind of dendritic atrophy. It can inhibit the birth of new neurons, making our library less capable of expansion. The ability to learn, to adapt, to manage new information becomes compromised. Now, what do you think might happen to the delicate balance of sleep when the brain, this master controller, is experiencing such profound structural shifts, when the very pathways meant to bring calm and restoration are altered by sustained tension? It's a compelling question, one that brings us to the threshold of our next contemplation. The worrying link to something as fundamental as our weight. Thank you for joining me, and I encourage you to explore the other lessons we have in this series. If you found this discussion helpful, perchance you might consider subscribing and giving it a thumbs up. Until we meet again, sweet dreams. Weight's worrying link. Whenever this delicate dance of hormones becomes disrupted, perhaps through the relentless march of chronic stress, or through the subtle yet profound changes in our sleep patterns, we begin to see a different picture emerge. For your body, you see, is a marvel of interconnected systems, and when one part falters, others soon feel the strain. The harmony, once so effortlessly maintained, begins to unravel, much like an ancient tapestry slowly losing its threads. You might be wondering, what then happens to this intricate balance? What precisely are the consequences when the very rhythm of our waking and sleeping hours is thrown into disarray by the persistent presence of stress? It's here that the story of neuroplasticity becomes particularly poignant. The brain, this incredible organ of adaptation, is constantly remodeling itself, a process we call neuroplasticity. It's how we learn, how we form memories, and how we adapt to change. But under the constant siege of stress, this adaptability can take a turn. Think of it this way: a sculptor can mold clay into something beautiful, but if the clay is constantly being pulled and pushed too forcefully, it can crack and lose its form. Much the same way, chronic stress can lead to maladaptive changes in the brain's delicate architecture. We observe, for instance, that prolonged exposure to stress can cause certain brain regions, like the hippocampus, crucial for memory and emotional regulation, to actually shrink. Neurons there might retract their delicate branches, losing vital connections. Conversely, other areas, such as the amygdala, which is deeply involved in our fear responses, can become overactive, even growing larger. What this means on a deeper level is that the very circuits responsible for our ability to cope, to learn, and to feel calm begin to function differently. It's not merely a feeling of being overwhelmed. It's a physical alteration within the brain itself, modifying how we perceive threats, how we process emotions, and how effectively we can lay down new memories. This intricate interplay between external pressures and the internal landscape of our minds is quite remarkable, shaping not only our immediate reactions, but our very capacity for long-term health. Sugar's stressful story. Weight, as we discussed, often holds a mirror to the quiet struggles within our bodies, reflecting the delicate balance or imbalance of our physiological rhythms. Now let us turn our gaze to a pervasive, yet often misunderstood, force that molds these rhythms, the very essence of prolonged agitation we refer to as chronic stress. What happens, you might wonder, when this feeling of unease becomes a constant companion, echoing through the corridors of our well-being? Think of it this way: acute stress, a sudden alarm, prepares us for a brief sprint. Our body mobilizes resources, quickens the breath, sharpens the senses, but chronic stress, that is akin to running a marathon without end, pushing our systems beyond their natural design. The body, resilient as it is, eventually begins to show the strain. One of the most telling signs, perhaps, appears in the intricate dance between stress and our fundamental genetic blueprint, specifically how stress can literally alter the way our genes express themselves. This silent alteration, known as epigenetics, doesn't change the genetic code itself, no. Rather, it acts like a dimmer switch, turning genes up or down, influencing their activity without rewriting the initial instruction. Imagine the grand score of life penned within our DNA. Epigenetics is the conductor, subtly guiding the orchestra, emphasizing some instruments, quieting others. Over time, persistent stress can persuade this conductor to favor compositions that are less than harmonious for our health. For instance, studies have illuminated how chronic stress can influence the methylation of DNA, a key epigenetic marker. Some research, for example, on those afflicted with Cushing's syndrome, a condition characterized by persistently high levels of cortisol, showed a decrease in this very methylation. What came to light was a compelling link between this diminished methylation and lingering neuropsychological consequences, a weariness that permeates the spirit, a persistent melancholy, and a gnawing anxiety. It suggests, doesn't it, that enduring high cortisol levels might actually reprogram our genetic expression, particularly in genes that moderate how sensitive our bodies are to these stress hormones. It is a subtle shift, yet its ripples can be profound. The stress of early life, perchance, leaves an even more indelible mark. Experiences such as childhood trauma or even the quality of maternal care can profoundly shape our epigenetic landscape. The delicate interplay between our genes and our environment, you see, is never more critical than in those nascent years. A traumatic childhood, for instance, has been observed to cast a long shadow, increasing the risk of neurodegenerative diseases, cardiovascular ailments, and even specific psychiatric conditions later in life. This is not merely a matter of memory or psychological impact. It is etched into the very fabric of our cellular being. These changes, often orchestrated through the mother's own stress response and her internal environment during pregnancy, can expose the developing child to an excess of these potent stress hormones even before birth. And after, the earliest interactions between a mother and her child, or the lack thereof, can further disrupt this delicate neuroendocrine regulation, contributing to behavioral challenges in adulthood. Perhaps issues with memory, an undercurrent of anxiety, or tendencies towards despair. This profound understanding reveals that the tales of our past are not merely stories we carry in our minds. They are inscribed in quiet ways upon our very biology. Chronic stress explained. Indeed, the narrative of the human body, much like an ancient manuscript, reveals itself gradually. We spoke of sugar's intricate role in our systems, and now, we must turn our gaze to a different kind of sweetness, or rather, a bitterness, the profound influence of chronic stress upon the delicate tapestry of the brain itself. Imagine, if you will, the brain as a magnificent, ever-changing garden. In this garden there are countless pathways and connections, constantly being pruned and regrown, a process we call neuroplasticity. This remarkable ability allows our minds to adapt, to learn, and to form new memories. However, when the harsh winds of chronic stress blow unceasingly, this garden begins to suffer. What happens precisely? Well, some areas of this garden, particularly those responsible for our emotional responses, like the amygdala, become overgrown, almost like an unruly thicket. The amygdala, often thought of as our brain's alarm system, grows more sensitive, more reactive. This heightened state of alert can lead to feelings of increased anxiety and a constant sense of unease. Conversely, other crucial areas, such as the hippocampus, which is vital for learning and memory, begin to wither. Instead of flourishing, its delicate branches and connections, known as dendrites, shrink. This retraction means that the pathways for forming new memories or recalling old ones become less efficient, less robust. It's akin to watching a prized plant slowly lose its vibrancy and strength, making it harder to absorb new information or even remember simple things. Then there is the prefrontal cortex, the part of our brain that quietly oversees our thought processes, our decision-making, and our ability to regulate emotions. Under the relentless strain of chronic stress, this area too begins to falter. Its functional flexibility diminishes, making it more challenging to focus, to make sound judgments, or to simply roll with the punches of daily life. It's as if the wise gardener, usually so adept at nurturing the plants, suddenly finds it difficult to direct their own efforts. You see, these changes are not merely fleeting. They are structural modifications, deeply woven into the very fabric of the brain. The same neural circuits that once helped us adapt to a temporary challenge can, under prolonged duress, become pathways for maladaptive responses that no longer serve our well-being but instead perpetuate the cycle of anxiety and distress. This is a subtle yet profound transformation, a quiet reshaping of our inner world. We shall next consider how this very reshaping can lead to a vicious cycle, drawing us deeper into the labyrinth of unease. The vicious stress cycle. Cause T neuroni K torich dendriti bili bike maz, ushnayat pod naparum dilugatralgo nipakaju, zaxanaja panoni rosquitak. To nixim budzeni siaspinigo agradu, jadizi kaz no polixeni jest drobnum, lexistitnim actum nadzii. I ko siko leki PRs of their persini diziologia w puyan spasab podubni, actuujak T same shlaki neuroplastics naskai T, K tor w spiaraja w zirost I laxnosk neuronelna. Zoozono z moga 1 not niwilo ek negatun z myani structuralni wiwilane stressum, a not w punim stop new adrakak atrophy neurono w hippocampi. Tatak jak bpr zarokli z dalnosk mozgu du regenerakji. Du odbudoi, pr zijizijmi sitemu blizzage, w pluna neurognes, si xylina prox turzinia sinoich neurono just tu kluxui. Strez zw lasks a 10 prs ulikli patrafi zamoak 10 delicatni prox, il lexeni w spierdes neuroplastics nosk zdage psygopanoni or chamiak. To jack pr zipmani mozgoi, z patrafi turzik iw zirastak. Ko wised 10 prox nipolga jedini na w zirasi w jednim absars. Wykazano, z terapites wiksajakas, ko nazuemi gestasia kolko dendritixnich. Sata malinki wipaski na dendritach, k tor sluzadu turzinia polexen z enemy neuronami. I am wisaj kolko, tim wisaj poting jelnich sizek communicacci, pomislmio tim, strez ten sichinisksasil nitilko wixerpudnasa energy. Nitilko zakloka nas sen il tax, w dilugoderminoid perspectui, ziminia sama architecture nas zigo mozgu. W plywina hipcamp, amygdalae cor pr zeg saloa, kluxu absari odpodzilni zapamek, emakjai pojmuni desizji. Ziemnie zona objetosk hippocampa, observoana u asab sirpiasich na chronics ni stress, depressed czy PTSD, jest tigo namikelnim daudum. Akota w shisko osnexa tu zinas mozg ni jest staticsna, nismina structura, jest dynamicsnim xywum goblinum k tori neistini tkai pr zet warzadoswixenia. I chok strez patrafi pozostawik na tim goblini swoj pietno, noka pokazud zimemi w sobi zdalnosk dunaproi duodporzania, du panonigo zinaj duania ronoagi, to jest w lasni ta fasinujaka plastics nosk, k tora dage nam nadzie. Nadzie natu zinot po nadsimnie sed nosi. Maz nadusk noi swit. Finding your calm harbor. The intricate dance between stress and sleep affects more than just our waking hours. It reverberates deep within our very cells, subtly altering the delicate balance of our biology. We explored this idea of a vicious cycle previously, and now, let's delve a little deeper into how our bodies remember stress, even when we consciously try to let it go. You see, the human body, much like an ancient archive, meticulously stores every experience, every perceived threat, right down to the molecular level. This is where the fascinating realm of epigenetics comes into play. Epigenetics, in its simplest form, refers to changes in gene expression that don't involve altering the underlying DNA sequence. Think of it this way: your DNA is like a grand, unchanging library of blueprints, but epigenetics are the sticky notes and highlights that tell your body which blueprints to read, when, and how loudly. What's particularly intriguing is how chronic stress, especially the kind born from prolonged uncertainty, can leave its mark on these epigenetic tags. Studies have shown, for instance, that sustained high levels of cortisol, our primary stress hormone, can actually alter the methylation patterns of our DNA. This reduced methylation, especially in genes that regulate our stress response, might explain why some individuals experience persistent fatigue, depression, or anxiety long after the initial stressful event has passed. It's as if the body maintains a heightened state of alert, even when the perceived danger has receded into memory. The impact of stress doesn't begin in adulthood, either. Indeed, the earliest chapters of our lives, even before birth, can profoundly shape our epigenetic landscape. Early life stress, such as adverse childhood experiences or even poor maternal care during infancy, has been linked to alterations in the methylation of genes like the glucocorticoid receptor. This receptor is critical for sensing and responding to cortisol. A subtle change here, and our stress response system might be wired differently for decades to come. Imagine a young sapling, its growth subtly influenced by the winds and soil of its first few years. Those early environmental cues, whether harsh or nurturing, can determine the strength and resilience of the mature tree. In much the same way, the experiences of early life lay down epigenetic patterns that affect a person's vulnerability or resilience to stress-related conditions throughout their lifespan. Even a mother's stress during pregnancy can subtly influence the developing fetus. Her experiences, her emotional state, can lead to increased methylation in certain genes within the newborn's umbilical cord blood. These minute alterations, these epigenetic whispers, may very well have functional consequences for how the child's own stress response system matures and reacts to the world around them. It's a reminder of the profound interconnectedness of life stretching back through generations. The implications of this epigenetic understanding are vast. It suggests that while chronic stress can leave a lasting imprint on our biology, the story isn't entirely set in stone. Many interventions, from improved sleep hygiene and social support to mindful practices like meditation and yoga, have been shown to influence these epigenetic markers. It seems that by tending to our minds and bodies, we might also gently persuade our genetic expression towards greater balance and well-being, and that, I think, is a thought worth holding on to. Mindful moments matter. Having explored how stress can ripple through our sleep patterns and the intricate dance of hormonal balance, we now turn our gaze to a deeper, more fundamental level: how stress subtly yet profoundly reshapes the very essence of our brain. Think of the brain as a magnificent ancient library, ever-changing, always adding new volumes or perhaps reorganizing existing ones. This capacity for change, this continuous reshaping, is what scientists term neuroplasticity. You see, our brains are not static. From the moment we are born until our final days, every experience, every thought, every interaction leaves its mark, subtly altering the neural pathways. This adaptability is usually a marvelous thing. It allows us to learn, to form memories, to heal from injury. It's what makes us truly resilient creatures. However, when stress, particularly chronic stress, becomes an unwelcome guest, this very adaptability, this neuroplasticity, can begin to work against us. Imagine a river that usually flows gently, carving a beautiful, meandering path. This is the healthy, adapting brain. Now picture a sudden, violent flood. The river's banks are eroded, new, harsher channels are gouged out, and the landscape is altered in potentially damaging ways. Chronic stress is much like that flood to our brain's delicate architecture. It doesn't just pass through, it leaves lasting structural and functional changes. One of the most impacted regions is the hippocampus, a small, seahorse-shaped area tucked deep within the brain, crucial for memory and emotional regulation. In healthy circumstances, the hippocampus is a bustling hub of activity, even generating new neurons throughout life, a process known as neurogenesis. But under the relentless pressure of stress, particularly the sustained release of stress hormones like cortisol, this vital region begins to shrink. The delicate branches of its neurons, called dendrites, retract, and the birth of new cells slows dramatically. This can manifest as difficulties with memory, a feeling that your thoughts are less clear. A sense of being perpetually foggy in the mind. Conversely, another area, the amygdala, often called the brain's fear center, responds quite differently to enduring stress. Instead of shrinking, the amygdala actually becomes more active, its neural connections strengthening and expanding. It's as if this part of the brain is put on high alert, constantly scanning for threats, even when none are present. This heightened activity in the amygdala contributes to feelings of anxiety, a constant state of apprehension, and can make it harder for us to simply switch off and relax. The balance, you see, is disrupted. The very regions that should help us calmly assess situations and safely store memories fade, whilst the alarm system grows ever louder. Body's gentle reset. W spomnilismi juz, jack mindfulness mas bike nixim delicatni pauju wyatru. Aspecadsi burs w nasim w netizu. Elko, jesli ta burs aprs erad zasai w kaspard zia uporksuigo. Kas ko w plywin sama structure na zigo snu. Nikidi boem stres nitilko zakloka nas agsusha. El rex ziminia architecture. Construct nas zigo unitas nigo swiata snu. Jack bw simnasiach narisol no plani, turzak labyrinth, wk torum trudno zinalisk droj du pradzuigo odpixinku. Wyabresi sobi, z silo mas woisteres liwask na strez, k tora naziwemi riktu nasia snu. Du jack bardzo trudnoskai zaisio w plywajananas sen, jest bardzo in daiwa duelni. Nikter osobi chak podin ogramnit prisji patrafia spak jack dizisa. In nizas, wistarksi nulki zmartwini by iknok stalasai polum bitwi budsich misli. Cizy sokarik du nasius nuag suwaja, zistrezniksim piasek w zegars, sipaisina expokani odpaxinek, widluzek cizaz zesipiani fragmented exen. Tanitilko trudnosk w zasnisiu, ali cizest budzeni sai, paxiusi, zisen nipiarzanosi prodzuigo eukogenia. Mazna tasobi wybrazik jako subtelni zimayani w siklech snu w tichtadnich podrazak piarzes leki fazi, sen gleboki I sen rem. Strez patrafi skrasik tinid bardzie regeneruges edipi, ziemniest at glebkosknes zigos enerzenia w niswietamosk. Nokausi w swoich sichich labor et oriech, piarzigladaj sitemo phenom noi za pomoka polisomnographia, to take noko nagruni snu. I ko widza. Gdy stressor, not nuilki jack noi dizwik w nosi, sizy nipkadzwazani zi koljnum dnim, pajawasai nispadzuni, sizas podazebni na zasnisi with luza sai. Akidi juz yuda sai zapask w sen, jest on plitzi piarzuruni, ziemniesa alasius nualnafalo ego, tigo nedgulb sigo, I snu rem, tigo, wk torum snimined bardzie intensuni. Observuj sai wisid piarzebuds and iemniesa ogolna effectunask snu. To gesto tile siko, ziludski umasalai silo rigujana stressori w spasab bardzo ziroznikauni. Kazdi zinaz ma swoja w lasna granis, po piarzekriksenu k torij, senzak zina sai burzik. Ujednich jest to nixim slabi most, k tori runi pod nuilkim obsiasnum, u inich. Nixim solid na constructja, zidalna widizimek naprod wheel, posistage white pitani, jack mosmi achronic 10 nas most prz zenisksenim, I czzy mosmi go wz machnik. Sleep your best defense. Now, as we near the close of our exploration into the science of stress, let us gently consider the profound impact that our early life experiences, particularly those moments shaped by stress and our social environment, have on the very fabric of our being, even down to the silent language of our genes. Imagine, if you will, the delicate tapestry of a young life, so easily impressed upon. The environment a nascent being encounters, from the warmth of the womb to the first gentle touch of a caregiver, can leave an indelible mark. Search, often using our small, whiskered friends, the rodents, as guides, has illuminated a fascinating truth. The interplay between early experiences and our genetic destiny is far more intricate than we once imagined. These experiences, both nourishing and challenging, don't just shape our memories or our temperament. They can literally alter how our genes are expressed without changing the genetic code itself. This is the realm of epigenetics. Think of it as a dimmer switch for our genes. Some experiences can turn certain genetic expressions up, others down. For example, when a pregnant mother experiences significant stress, the elevated levels of stress hormones she carries can epigenetically modify her offspring's developing systems. This might lead to heightened stress reactivity or even predispositions to certain emotional states later in life. It's as if nature provides a subtle warning, preparing the new life for the world it expects to inhabit. A world that, perchance, felt a little less secure to the mother. Yet this story is not one of mere vulnerability. The quality of maternal care, for instance, has been shown to have a deeply protective epigenetic effect. Pups that receive more attentive care from their mothers often exhibit reduced stress responses, become more exploratory, and show improved cognitive functions. It is as though the gentle caress and consistent presence of a nurturing figure can switch on genes that promote resilience, turning down the volume on those that might amplify anxiety. Conversely, environments lacking such care or marred by aggressive interactions can lead to epigenetic changes that foster heightened stress reactivity and impairments in memory and learning. It's a quiet testament to the enduring power of connection. What this means is that stress, especially during the formative chapters of life, sculpts us from the inside out. It influences intricate molecular mechanisms like DNA methylation and histone modifications, which then go on to control gene expression. And these alterations, these subtle shifts in our genetic landscape, can profoundly affect our neurobiology and behavior for years to come. Such insights remind us of the vast and interconnected web of life where even the smallest interaction can resonate through generations. It underscores the profound importance of nurturing care and the protective embrace of a supportive environment, especially when existence at its edges feels a touch uncertain. We are, it seems, quite literally shaped by the stories we encounter from our very beginning. Embrace peaceful evenings. Earlier we spoke about the profound role sleep plays in defending your body, a silent guardian, if you will, against the wear and tear of daily life. We touched upon how a good night's rest helps to keep the delicate balance within you. But what happens when that balance is repeatedly disturbed by the persistent whispers of stress? Imagine the brain, a vast and intricate city, where every thought, every emotion, every memory leaves a faint trace. Now when stress enters this city, especially chronic stress, it doesn't merely pass through quickly. No, it begins to rearrange the very architecture of its most vital districts. This is what scientists call neuroplasticity, a concept that describes the brain's ability to change and adapt. While often a beneficial process enabling us to learn and grow, under the relentless assault of stress, it can take a darker turn. Think of the hippocampus, that quiet library within your brain, crucial for forming new memories and learning. Under acute stress, it can perform quite admirably, focusing its resources. Yet with chronic stress, it's as if the library begins to crumble. Dendrites, the delicate branches of neurons that receive information, start to retract. It becomes harder to place new books on the shelves, to recall existing ones with ease. This leads to impaired memory and learning, a fog that descends upon the mind. Then there is the amygdala, often thought of as the brain's alarm system, sensitive to fear and anxiety, while helpful in moments of danger, enabling a swift response. Chronic stress can cause it to become hypersensitive. It's like an alarm bell that rings incessantly, even when there's no immediate threat. Here, dendrites might not retract, but rather they expand, becoming overly excitable. This leads to heightened anxiety, a feeling of being perpetually on edge, even in moments of calm. And the prefrontal cortex, that executive office of the brain, responsible for thoughtful decision-making, planning, and regulating emotions. Its function also suffers under chronic stress, becoming less efficient, less able to exert its calming influence over the amygdala. It's a bit like a well-meaning manager whose desk is perpetually overflowing, unable to get ahead of the constant demands. This can manifest as difficulty in making decisions, a struggle with emotional regulation, and a general feeling of being overwhelmed. What this means is that the very structures of our brain, designed for adaptation, can be reshaped by prolonged exposure to stress, leading to vulnerabilities that may contribute to mood disorders and cognitive difficulties. It truly is a remarkable, if sometimes unsettling, testament to the profound connection between our experiences and our biology. How the echoes of stress can reverberate through the silent pathways of the mind, etching themselves into its very fabric. But this reshaping is not irreversible, nor is it without hope. However, that is a story for another time. For now, let us consider what might alleviate some of this internal disquiet. Rest, reset, recharge. So we arrive now at the culmination of our quiet journey, our understanding of how profoundly stress can weave itself into the very fabric of our being, from the fleeting moment to the subtle shifts in our genetic expression. We've seen how the body's ancient alarm system, that intricate dance between the brain and the adrenal glands, orchestrates changes in our sleep, our metabolism, and even the very architecture of our minds. It is a testament to nature's profound wisdom. That the systems designed to protect us can, when overtaxed, begin to undermine our delicate balance. Indeed, the science of stress reveals a complex tapestry. We've discovered how stress, particularly if it is chronic, can alter the landscapes within our brains, reshaping the hippocampus, a seat of memory, and the prefrontal cortex, our conductor of thought and emotion. It is as if the persistent pressure of a river can, over time, change the very course of the land it flows through. These are not mere abstract concepts, but the very real physical consequences that can manifest in our emotional well-being, our cognitive clarity, and our ability to find true repose. Consider this: the subtle epigenetic shifts that can occur, almost like footnotes added to our genetic code by the experiences we endure. These tiny modifications, triggered by the environment and especially by stress, can influence how our genes are expressed. Think of it as a dimmer switch, subtly turning up or down the volume of certain genetic instructions without ever changing the song itself. This is perhaps one of the most remarkable discoveries of our time, that our life experiences can leave an imprint that reaches down to our very cells, potentially affecting not just us, but future generations. It is a profound thought, is it not? The beauty, perhaps, lies in the reciprocal nature of our systems. While stress can indeed carve these deep pathways, our bodies also possess an innate capacity for resilience, for healing. Understanding these mechanisms is not meant to create anxiety, but rather to illuminate the path toward greater harmony. Simple, gentle choices in our daily lives, a moment of stillness, a conscious breath, the quiet discipline of a peaceful evening routine, can become powerful currents flowing in the opposite direction, slowly, patiently, restoring balance. And so, as our lesson draws to a close, I hope you feel a little more at peace with the intricate workings of your own body and mind. It truly is a marvelous machine, capable of exquisite adaptation. Thank you for joining me on this quiet exploration. If this journey through the science of stress has brought you a measure of calm, I invite you to consider subscribing to Bedtime Lessons and perhaps give this video a gentle thumbs up. Exploring the quiet echoes of knowledge can be a most comforting endeavor, and there are many more tales to tell within these archives. I hope to share them with you again very soon. Sweet dreams.